Okay, let's look at problem number 2 in 8.4. Data show that men between ages 20 and 29 in a general population have a mean height of 69.3 inches with a standard deviation of 3.1 inches. A baseball analyst wonders whether the standard deviation of heights of Major League Baseball players is less than 3.1 inches. The heights in inches of 20 randomly selected players are shown in the table. Okay, you've got a table this time that gives you the data. This is homework, so you could go directly into StatCrunch, or if we were on a test or quiz, we could copy it to the clipboard and then hit Control-C, go into your StatCrunch table, and hit Control-V. Okay, so now we've transferred it. It's all there. So let's finish the problem. What is the correct hypothesis? What are you trying to test? It says a baseball analyst wonders whether the standard deviation of heights of Major League Baseball is less than 3.1. So that's what we're trying to test, less than. The standard deviation would be equal to for the null. The standard deviation would be less than for the alternative. Okay, we want to calculate the test statistics. So we're going to go to Stat, we're going to go to Variance, we're going to go to One Sample, and this time we want to do with data. The data was in the column that was called Bars 1. Now, the hypothesis test. The standard deviation that you found in your sample was 3.1. So we need to do what? Okay, the 3.1 was in the sample, so it's taking care of that part already itself. Now, what are we testing? We're testing that it is what? Less than 3.1. Well, I need to square 3.1 before I put it in. So if you want to pull up some kind of calculator, and do 3.1 squared. 3.1 squared. Okay, what do we get? 9.61. 9.61. So that's what we need to put in for the sigma squared. And remember, that is the variance. It is the standard deviation squared. And this time, we're testing less than. So let's remember to make that change, or we'll get some of our answers wrong. All right, what is your chi-squared? To 3 decimal places, it is 8.137. 8.137. Okay, the p-value to 3 decimal places, and be sure you watch because they swap between 2, 3, 4 all the time. 0.01 instead of 4, it would be 5 for 3 decimal places. Okay, that's our p-value, 0.01, and we are testing at the 0.01 significance level. Even though they're both very small, the p-value is still greater than the significance level. So therefore, we do not reject. There is what? Not sufficient evidence. All right.